Hi, good afternoon, everyone. So today we are going to go ahead and we are going to begin with the revision of statistics. The topics that I have in mind for today, क्या करना है? We need to do basically all measure of central tendency, mean, median, mode. We'll do skewness, Kurtosis. We'll do movements. ठीक है? Then we will go ahead and we will talk about standard deviation and all other measures of deviation. And then we will be talking about correlation. And then we will talk about simple regression model. Abhi ke liye I have this in mind. If time permits, we'll start with probability. But tomorrow we will do probability and its different distributions and wrap up stats. I need full attention throughout the lecture. बहुत सारी जगह पे I will ask you read this formula, read that formula. You have to make sure कि ये जो भी book I have created today, you will go ahead and you will read it thoroughly. जितना भी formulas I have given, you will do them thoroughly. ठीक है? It has not yet been uploaded on the portal. मैंने just last moment में से complete किया just a minute back. So it will be uploaded on portal only after the lecture has been completed. Okay, now let's begin. So the first thing which is important is that what are the different type of statistics जिसमें we need to understand that there are two kind of statistics. एक को हम बोल देते हैं descriptive statistics और एक हो जाता है inferential statistics. Descriptive statistics means basically any statistics which is going to go ahead and describe the data set as the word suggests, right? Whereas when we talk about inferential statistics, जो हम probably we'll take it towards the end, that is hypothesis testing, where we infer statistics में different things from it. Infer means we understand, we take out some result out of the data set. We inferize the data set, right? So descriptive में basically we are describing the data कि what is the average of the data, how to organize the data, how to present the data. Basically हम data के beyond नहीं जा रहे हैं. We are not going beyond the given data set. ठीक है? So mean, median, mode, range, variance, standard deviation, quartile deviation, ये जितना भी चीजें हैं, these are all part of your descriptive statistics. ये सबको ही हम descriptive statistics बोलते हैं. Whereas when we go ahead and when we talk about inferential statistics, inferential माने we infer, माने हम infer means what? Infer means we use data to give conclusion about the data. So in a way हम पूरा population में से we use a sample and sample is used to draw conclusion. ठीक है? तो इसमें हो गया आपका पॉइंट एस्टिमेशन, कॉन्फिडेंस इंटरवल, हाइपोथेसिस टेस्टिंग, टी टेस्ट, जेड टेस्ट, काई स्क्वायर, एफ टेस्ट, रिग्रेशन, कोरिलेशन, जिसमें भी we give some conclusion. You know what? I think there is high correlation between the two. I think that my data is between this interval from this to this, right? तो जहां पे we go ahead and where we go and draw conclusion about the data set, उसको हम inferential statistics बोल देते हैं. ठीक? So this is the first thing which all of you will read. Then you also have different kind of variables जिसके basis पे statistics can be defined. Univariate means one variable, single variable. Bivariate means two variable. Multivariate means many variables. ठीक है? अब हम आ जाते हैं scale of measurement पे. So there are four main scale of measurement. ठीक है? Scale of measurement पे there is a chance कि एक MCQ question, one MCQ will be asked इस पे on the different scales of measurement. So all of you have to go ahead and understand these. So when we talk about the first scale of measurement, that is basically called as nominal scale. Nominal में क्या होता है? That we have data which is labeled, right? There is no ranking, there is no numerical meaning to it, like blood group A, B, C, D, right? Or sorry, A, B, and O. These are the blood groups, right? A, B, O. बट इज देयर एनी रैंकिंग? क्या हम ऐसा बोल सकते हैं ए इज बेटर देन बी इज बेटर देन दिस? नो, देयर इज नो बेटर ग्रुप, ब्लड ग्रुप, राइट? सो नॉमिनल स्केल इज जस्ट क्लासिफिकेशन विदाउट ऑर्डर, कोई ऑर्डर नहीं है। लेबलिंग तो है, बट वी कैन नॉट से दैट वन इज बेटर ओवर द अदर. Political parties, we cannot say one is better than the other. Gender, male and female, but there is no ordering. We cannot say which is better. ठीक है? So in nominal scaling there is no ordering, just labeling. उसके बाद आता है ordinal scale. Ordinal scale is ranking. You can rank the data set. Order matters, but differences does not. Just for example, if I say a student is first in class and a student is second in class, ठीक है, अब फर्स्ट स्टूडेंट कैन गेट 99% एंड सेकंड कैन गेट 95%, या फर्स्ट कुड हैव स्कोर्ड 99% एंड सेकंड कुड हैव स्कोर्ड 98.9%. डज इट मैटर कि क्या डिफरेंस है? इट डज नॉट. डिफरेंस से फर्क नहीं. आई एम ओनली इंटरेस्टेड इन अंडरस्टैंडिंग हु केम फर्स्ट एंड हु केम सेकंड, राइट? सो आई कैन रैंक द डेटा सेट. डेटा रैंक तो हो सकता है, बट इसमें वी कैन नॉट गो अहेड एंड वी कैन नॉट टेल द रैंकिंग. ऑर्डर तो मैटर कर रहा है, बट ये सॉरी द डिफरेंस, बट डिफरेंस मैटर नहीं कर रहा. इट डज नॉट मैटर कि डिफरेंस 5% से है, 7% से है या 0.1% से है. ठीक है? सेम वी कैन से पॉवर्टी लेवल. ठीक है? तो मैं बोल सकती हूँ पॉवर्टी इज लो, पॉवर्टी इज मीडियम एंड पॉवर्टी इज हाई इन अ कंट्री. हाई पॉवर्टी मीन्स मेनी पीपल विल बी बिलो पॉवर्टी लाइन, बहुत लोग पॉवर्टी लाइन के नीचे हैं. लो पॉवर्टी मीन्स कुछ लोग पॉवर्टी लाइन के नीचे हैं. सो ओके फाइन, वी अंडरस्टैंड व्हाट हाई, मीडियम एंड लो मीन. कुछ तो रैंकिंग हो सकता है, बट आई कैन नॉट टेल यू द डिफरेंस, राइट? सो दैट इज नॉट देयर. Then the third one that we have is that is called as interval scale. अब interval scale में what happens is that I can actually go ahead and I can tell you the difference as well. तो जैसे for example when I say IQ score, so now I can tell you the difference between the different score of students. When I go ahead and when I tell you the temperature, तो I can tell you ना that what is the difference between temperature in Delhi and Bombay, कितना difference है. So we can go ahead and we can measure the difference, and difference is meaningful. Difference का कुछ मतलब है. The difference means something, right? So this is what is called as interval scale. And at last we have something which is called as ratio scale. So ratio scale, basically what happens is that in a ratio scale we have equal intervals, right? In a ratio scale basically we have there is presence of true zero also, right? Whereas in an interval scale there is no, I mean zero is arbitrary, zero is not absolute, right? So for example, I'll give you another example to understand this thing. Just when I talk about interval scale, a calendar year is an interval scale. ठीक है? तो आई कैन गो ahead and I can tell you कि 2025 से 2027 में कितने years का gap है, right? I can measure in terms of days also. There is no starting point really, right? That starting point zero is arbitrary. ठीक है? I can start from 2025 and I can go till 2027. I can start from 1993 and I can go till 2027. I can start from 1987, I can go till 2027. माने there is no, the zero is arbitrary. I am choosing from what to what. ठीक है? But when I go ahead and when I talk about the ratio scale, then in ratio scale true zero exists, right? For example, weight, right? So when I say my weight is this many kgs, I know I'm starting from the actual zero. Zero से ही कितना difference है, right? When I say height, I know I'm starting from 0 centimeter to a certain centimeter. When I say age, I know 0 years से start होके I have reached a certain age, right? So when I say ratio में comparison भी है, difference also means something, but a true zero value also exists. ठीक है, so these are the different things that you have. You will read it through. ठीक है, I have measured this. I have written it here also. 0 means something here, and this is the scale comparison. Read it. ठीक है, now let's talk about the different measures, जिसमें हम सबसे पहले बात करेंगे about mean. When I talk about mean, तो basically mean में there are going to be the different kind of questions जो इसमें आ सकते हैं. सबसे पहला तो we need to go ahead and we need to understand the basic formulas of mean. Then we need to understand what is grouped mean. Then we need to understand mean when a wrong value is given. उसके बाद you need to understand geometric mean, harmonic mean, and relation between AM, GM, and HM, and last, weighted average. मीन में ये सारा चीजें इंपॉर्टेंट है. ठीक है, फर्स्ट ऑफ ऑल लेट अस गो अहेड एंड लेट अस टॉक अबाउट द बेसिक फॉर्मूला ऑफ मीन. So basic formula of mean, all of us know. Whenever we have to write about mean, mean is nothing but summation xi by n. Right? Now, whenever you are given frequencies for x, जब भी हमें x का frequency दिया होगा, माने I'm given x is 1, 2, 3, 4 and इसका कुछ frequency given है. 1 का frequency 5, 2 का frequency 1, 3 का frequency 2, 4 का frequency 2. Then the formula of mean will become summation x into frequency upon sum of the frequencies. ठीक है, if you are given a continuous data set, so for example, if I am given that my x is 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, और यहाँ पे ना हमें कुछ frequencies भी given है, fx भी given है. I'll take the same, suppose 5, 1, 2, 2, 3, ऐसा कुछ given है. Then we can go ahead and we can find midpoint. Midpoint is lower value plus upper value or higher value. So lower interval value, upper interval value divided by 2. तो माने first का midpoint हो जाएगा 0 plus 10 by 2. 10 by 2 is 5. Then 10 plus 20, 30 by 2, 15. 20 plus 30, 50 by 2, 25. 70 by 2, 35. 90 by 2, 45. अब midpoint आने के बाद you will simply use the formula summation m into fx by summation fx. So you will multiply this. Okay, this is, sorry, 135 now. You will multiply this and add this together. ये आपका numerator होगा. You will add this together and this will become your denominator. Okay, so this is basically called your data set with your continuous interval. अब suppose आपका जो डेटा है वो थोड़ा सा कॉम्प्लिकेटेड है. ठीक है, the frequencies are very high, the intervals are very high, so we can go ahead and we can work with something which is known as assumed mean. With the presence of assumed mean, the formula of mean becomes A plus summation F into D upon summation F. This is, for example, let's say मेरा data set है 100, 102, 105, 107, 109. It's a big data set, big numbers आते हैं. और इनका कुछ frequency दिया हुआ है fx 1, 2, 3, 1, 2, कुछ ऐसा. Then what I can do is I can take some number as assumed mean and I can find deviation. तो deviation हो जाएगा x minus assumed mean. So 100 minus 5 minus 5, 102 minus 5, 100 and minus 3, 0, 2 and 4. And then I can find D into F. So I can multiply this together, add this. This will become my numerator here. Add the frequencies together. So 3, 4, 5, 6, 7, 8, 9. And this will become my denominator. So my formula will become assumed mean 105 plus जो भी यहाँ पे आंसर होगा 8, 9, 10 minus 11 minus 1 upon the sum of the frequencies, which is 9. This will be your mean. Right? So we can use the formula of assumed mean also. Assumed mean में कुछ नहीं करना है. You take a value, center point पे कुछ value ले लो. That becomes your assumed mean. Assumed means you're assuming कि mean will be very close to 105 because it lies in the center. So you have taken some assumed mean. Then you find the deviation by doing x minus a, and then you just do d into f and you use this formula. Sometimes ये जो हमारा D होता है, this may also have something in common. जैसे for example, अगर ये होता data 1000, 1020, 1050, 1070, 1090, तो when we would have found out the difference, जब हम D निकालते, I would have got minus 50, minus 30, 20 and 40. माने इसमें you would have noticed that when you find D में कुछ कॉमन निकल रहा है. Like here, all of them are multiple of 10. So then you can go ahead and you can find a variable first and उसको you can call that as D dash. और ये D dash क्या होगा? ये D dash हो जाएगा D divided by H, where H is the common height. तो यहाँ पे divided by 10 if I do, I will get minus 5, minus 3, 0, 2 and 4. And in this case, my formula of mean will become A plus summation F into D dash divided by summation F into the height. एक ही बात है. I have divided it by height and then multiplied it back with height. ठीक है? So this is the only thing which you have to keep in mind. Any doubt in this? Anyone? Okay. Now we can move on to weighted mean. So when we talk about the weighted mean is basically summation W into X by summation W, where W is the weight given. अब यूजुअली ये कहाँ यूज होता है? द वेटेड एवरेज मीन इज यूजुअली यूज्ड इन प्राइस इंडेक्स या क्वांटिटी इंडेक्स, राइट? सो फॉर एग्जांपल, इफ आई टेल यू दैट आई एम गिवन फूड का क्वांटिटी 100 kg, 150 kg, 120 kg, and I am given weights, and weight is based on the price of the food, right? Like price is 2, price is 3, price is 2. And I ask you find the average quantity of food. कुछ नहीं करना है. You will do summation x, I'm calling this x only, into w by summation w. तो इसको I will multiply. ये हो जाएगा 200, 450, 240, 09448, 890 divided by 3, 4, 5, 6, 7, and ये आपका weighted mean आ जाएगा. This will be your weighted mean. ठीक है? उसके बाद we have the formula of combined mean. Combined mean is usually used whenever you are given some groups. Groups माने suppose you are given males and female, and in दोनों केस में you are also given their wages. आपको उनका wage भी दिया हुआ है. So whenever we will find combined mean x bar, I can call this as C. This will be number of the first group into the mean of that group plus number of people in second group into the mean of that group upon the total number of people. Combined and group mean is same, huh? Mean is equal to A plus summation F d by f, where d is a minus a, x minus a by h. No, if you're dividing by h, you have to multiply back by h. See, here if I divide by h, I have to also multiply back by h. So it will be summation f into d dash into h. ठीक है, तो ये हो गया हमारा कंबाइंड मीन. अब द नेक्स्ट थिंग, हाँ, कंबाइंड मीन इज ऑल्सो कॉल्ड एज ग्रुप मीन. करेक्ट. अब आ जाते हैं हम ज्योमेट्रिक मीन पे. प्राइजेस विल ऑलवेज बी कंसिडर्ड एज वेट ना, नॉट नेसेसरी. माने अगर प्राइस इंडेक्स निकाल रहे हो तो क्वांटिटी कैन ऑल्सो बी द वेट. ऐसा कोई कंपल्शन नहीं है. ठीक है. ओके, नाउ लेट्स टॉक अबाउट ज्योमेट्रिक मीन. Geometric mean is very simple. There are two formulas of geometric mean. First formula is that it is x1 into x2 till xn to the power 1 by n. ठीक है. और अगर ये gm है, if this is gm, x1 into x2 till xn to the power 1 by n, so we can take log on both sides and I can get log gm is equal to log x1 till xn to the power 1 by n. And we know log m to the power n is n log m. So ये जो this factor, this can come here. So we will get log gm is equal to 1 by n log x1 till xn. So this is nothing but log gm is equal to 1 by n. अच्छा, then I know कि log m n is log m plus log n. So I can add them together. It will be log x1 plus log x2 till log xn. So this will be summation log xi, I from 1 to n by n, log gm. So gm will be take antilog, summation log xi, I from 1 to n by n. This is another formula. I think ये notes में मैंने नहीं दिया है. So you make a note of this somewhere here. One formula is this, GM का. And the other formula is this. Okay. So nothing. I have just taken log on both sides. So when I take log here, this becomes log GM. If I take log here, it becomes log into this. I've just used the property log m to the power n is n log m. So this power comes down. So power has come here into this log. Then I've used the property log m into n is log m plus log n. So since all of them are getting multiplied, they will come separately in addition. So it becomes log x1 plus log x2 till log xn. So I've just generalized it and written summation log xi. और उसके बाद क्योंकि ये log gm इक्वल टू दिस था, तो gm माने जब log दूसरी साइड जाएगा it will become anti-log. So I've just taken anti-log here and this is the answer. Yes, माने so no, it depends what formula you want to use. So जैसे for example, if I say find gm, if I say find gm of 4, 5, 6, 7. तो method 1 will say कि gm is equal to 4 into 5 into 6 into 7 to the power 1 by 4. And method 2 will say gm is equal to anti-log of log 4 plus log 5 plus log 6 plus log 7 divided by 4. Up to you. You can use any using calculator. Log values will be given. Otherwise, you can use this formula using calculator. Anyways, you will be given a calculator. Huh? Okay. So this becomes your GM ka formula. Then you have harmonic mean, HM. So harmonic mean में there are two formulas. एक simple harmonic mean है, which is n upon summation 1 by x, and एक weighted harmonic mean है if weights are given, which will be summation w upon summation w by x. Depends again कि what question is given to you. So I'll just give you an example of this. जैसे if x is given as 1, 2, 3, 4, तो 1 by x will be 1 by 1, 1 by 2, 1 by 3, 1 by 4. So this formula will become 4 divided by 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. ठीक है? There is a video on index number, beta. You can refer to microeconomics. Index number पे complete lectures provided है. So we can take them, but don't say that it's not on the portal. ठीक है, तो ये आपका हो गया HM. Now let's talk about the relationships. So AM is greater than equal to GM is greater than equal to HM. This is the relationship between AM, GM and HM. ठीक है. Now इसी में just remember कि sometimes they ask you mean deviation. ठीक है, mean deviation about mean. ध्यान से समझो. Why two mean are coming? Mean deviation means आपको average निकालना है. Average किसका? Average of deviation. About mean means you have to subtract each value from mean. किससे deviation निकालना है? From where you have to find the difference? From mean. And what you have to do? You have to find the average. So mean deviation about mean का meaning क्या हो गया? Mean deviation about mean means summation xi minus x bar divided by n. ठीक है? And if frequency is given, summation f xi minus x bar upon summation f. These are your formulas of mean deviation about mean. ठीक है? तो for example, let's say कि I have a data 1, 2, 3, 4, 5 and I know कि इसका mean comes out to be 3. So I will find xi minus x bar. So 1 minus 3 minus 2 minus 1, 0, 1, 2. I will find its absolute value. So 2, 1, 0, 1, 2. I will add them 2, 2, 4, 1, 5, and 6. So mean deviation about mean will become 6 divided by 5. What will be the formula if there is frequency in HM? This we did, right? Only W will be replaced with frequency. W is kind of frequency only. Weight and frequency, there is not much difference. हाँ जी. Any doubt, anyone? ठीक है. तो अब एक और कॉन्सेप्ट आता है. इट इज अ हाई प्रोबेबिलिटी दिस ईयर कहीं ना कहीं यू मे सी दिस क्वेश्चन विच इज ऑन ट्रिम्ड मीन. इट्स एन इम्पॉर्टेंट कॉन्सेप्ट जो स्टैट्स की डिवोर में कवर्ड है. So if you ever find time, I think it's covered in my stats videos also. You do them. Trimmed mean. तो trimmed mean का meaning क्या है? Trimmed mean is very simple. Trimmed mean just goes ahead and says that we want to find mean after going ahead and after removing the outliers. Because mean is getting affected by outliers. Mean outliers से बहुत ज़्यादा affect हो जाता है. So what we want to do is we want to reduce the influence of outlier. जैसे for example, my data is given to me and ये डेटा ऐसा कुछ है 0 0 1 2 3 4 5 100. अब clearly this 100 is an outlier. वो data से it's not matching. And I know कि if I will find the mean, so the mean will become very close to 100 even if most of the observations are very less than 100. Right? So 1 2 3 4 5 6 7. You find the mean, ये mean बहुत closer to 100 आएगा. Even though it should not be that close to 100. So in that case, what we want to do is we want to reduce the influence of the outlier. So when we want to reduce the influence of outlier, what we can do is we can say find p% trimmed mean. Find p% trimmed mean. And p% trimmed mean का क्या meaning है? माने you reduce the data by p% because ये 100 बहुत highly misleading है. The value of this 100, this is very misleading. So we have to remove this. हमें ये हटाना है. How can we remove it? So suppose this p can be anything. Suppose if I ask you find 25% trimmed mean. Right? So you remove 25% data from both ends. Suppose I'll add one more value. Let's say I. So that calculation thoda easy ho. So 0, 1, 2, 3, 4, 5. And say I have 0.25 also here. There are 8 observations. So 25% of 8 will mean 25 by 100 into 8. So it will be 2. That means I have to remove 2 observations. Right? So I have to remove 2 observations. कहाँ से? From each side. I will reduce 2 observations. 2 हटाओगे, but you will reduce them from each side. तो माने you will reduce these 2 observations and you will reduce these 2 observations. And then you will find the mean of the remaining observations. ठीक है? So this will be called as trimmed mean. Trimmed mean का मतलब होता है, meaning of trimmed mean is you reduce certain observation from both sides so that you get better accuracy by removing the outliers. Okay, I'll zoom out. What if answer is in decimal? Then you take an approximate value. Then you remove 2. 1.75 is closer to 2 now. Done. Again, okay. So we are talking about trimmed mean. Trimmed mean माने we are talking about removing the outliers. Outliers को हटाने के लिए जो भी हमें परसेंटेज दिया होगा हम उतना डेटा दोनों साइड से हटाएंगे. जैसे if someone tells you find 10% trimmed mean and 8 observations are given to me. So I will find 10% of 8. ये आ गया 0.8. Right? Which is approximately 1. माने आई विल रिमूव वन ऑब्जर्वेशन फ्रॉम बोथ साइड. तो एक यहां से ऑब्जर्वेशन हटा दो और एक यहां से ऑब्जर्वेशन हटा दो. And you find the mean of remaining observation. So remaining observation will be 0.25, 1, 2, 3, 4, and 5 divided by 6. This is called your 10% trimmed mean. Yes, when 2.5, it's your discretion. You can take 2 or you can take 3. It's because it's exactly the center. Clear हुआ ये बात? Okay. Now, so let's go ahead. I hope mean से related सब कुछ clear है. Let's take few questions, then we will proceed. Solve. Put data in ascending order. Yes, only then I know the outliers. Of course, yes. Random data में how would I know the outliers? Okay. So you have to tell me if it is true or false. Okay. So if AM is equal to GM, right? Then all observation must have been equal. Think. By tomorrow, I will add a stats का MCQ book for all of you. Practice that, huh? Before your exam, वो जरूर करके जाना है. So we will look for two uh, two observation data set. So if there are just two observation, AM will be what beta? X1 plus X2 by 2. And GM will be what? X1 into X2 under root. So I am saying X1 plus X2 by 2 is equal to X1 into X2 under root. So X1 plus X2 is equal to 2 X1 X2 under root. So if I square both sides, X1 plus X2 whole square is equal to 4X1 into X2. X1 square plus X2 square plus 2X1 X2 is equal to 4X1 X2. X1 square plus X2 square minus 2X1 X2 is 0. So X1 minus X2 whole square is 0. That means if I equate it to 0, X1 will be equal to X2. है ना? So yes, if AM and GM are equal, then it must have been true that the observations would have been equal. All observations are same. Correct. Okay. So again, true or false? 50% trimmed mean is a special case of median. yes, correct, true हो गया ना. 50% trimmed means माने क्या? From the entire data set, I have removed 50% of observation from here and 50 from here. माने I am left up with only the centermost observation. And what is median? Median is that centermost observation. So, yes, that is correct. That 50% trimmed mean is approximately nothing but the median only. Right? So, it is the same thing. Okay. Now, so match the following. Give it a try. Okay, fine, good. Harmonic mean, grouped mean, wrong values, geometric mean. ठीक है. Now, suppose if I tell you that the mean of 40 students of section A marks is 60 and the mean of 60 students section B is 50, find mean of class as a whole. ठीक है, I'll do a question on wrong value, don't worry. Find mean of class as a whole. Correct. So mean of 40 students दिया हुआ है 60 and 60 students दिया हुआ है 50. So combined mean will be 40 into 60, 60 into 50 divided by 40 plus 60. Just find the value, huh? Whatever the answer is. Okay. Now suppose I reverse the question and you are given that mean of 30 students is 20, right? Combined mean is 26. Find mean of another group if there are 20 students in it. Do it. You're given combined mean is 26. So combined mean is x1 into n1 plus x2 into n2 upon n1 plus n2. Combined mean is 26. Mean of 30 student is 20. And second mean I don't know. But I know that there are how many students in it? 20. And denominator is n1 plus n2. Okay. Okay, so you can just find the value of x2 bar. Use it in this equation. Okay, okay. So you're given कि AM of two number is 10 and HM is 8. You have to find GM. So I think we didn't write the formula. GM is AM into HM under root. What would be the answer? Good. Okay. So you can just put it here 10 into 8 under root and that will be your GM. Okay. Okay. Now one last thing is whenever we have to go ahead and we have to do a wrong value question. So for example, if you are given that the mean of say 20 observation is 40, right? And later it was found that one value which was 30 was wrongly taken as 50. Mane correct value is 30 and you had taken as 50. Find correct mean. So mean of 20 observation is 40. There was one value which you had wrongly taken at 50, but it should be 30. So what will be the formula of correct mean? It will be summation x into f, right? Yes, summation x into n, right? Minus wrong observation plus correct observation divided by number of observation. So you will find the total 40 into 20, 800. You will subtract जो आपने गलत observation लिया हुआ था. You will add back the new observation. So this will be your new sum and divided by the number of observations. And this will be your corrected mean. ठीक है? Clear? You can do this for multiple observation also. माने अगर ऐसा कुछ दिया होता that the mean of 25 observation is 60 and two values were wrong, 45 and 80. And the correct value should have been say 60 and 100. So you can do the same formula for this also. So you will do 25 into 60, subtract the wrong observations, add the correct observation, and divide by the number of observation. तो जितना भी observation given है, it does not matter. You will go ahead and find summation x into f, subtract the wrong observations, add the right observations, and divide by the number of observations, right? Okay, so with this we come to the end of mean. Now let's talk about median. Read, 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 read. This as well, this as well. Very important. Read all properties जो भी यहाँ दिया हुआ है of mean. अगर मीन से क्वेश्चन आएगा प्रॉपर्टीज में, ओनली दीज प्रॉपर्टीज विल बी आस्क्ड, सो यू हैव टू रीड देम very carefully and make sure that you write notes on them. ठीक है, चेंज ऑफ स्केल, ओरिजिन, एवरीथिंग. ओके, नाउ लेट्स टॉक अबाउट मीडियन. सो मीडियन का मीनिंग हो गया दैट यू आर बेसिकली टॉकिंग अबाउट द मिडिल वैल्यू, वॉट एवर डिवाइड्स द डेटा सेट इन हाफ. ठीक है, सो अब मीडियन में 50% of the observations are below and 50% of the observations are above. Median is also called as positional average because it tells you the position. It is not affected by extreme values. Outliers से उससे मतलब नहीं है because it is talking about the center value, right? How do we find median? To find the median of individual data, first you arrange them in ascending order. If there is odd number of data, then it will be n plus 1 by 2th observation. And if it is even, then it is going to be n by 2th observation plus n by 2 plus 1th observation divided by 2. ठीक है, तो ये हो गया आपका even. जैसे for example, if you have 2, 4, 6, 8 even observation, so it will be 4 by 2 of 2th observation plus 4 by 2 plus 1th observation divided by 2. माने second observation plus second plus 1th observation by 2. So second observation plus third observation by 2. So second observation and third observation 4 plus 6 by 2. ठीक है, so this will be your formula of median. अब whenever you are given a median where you have discrete distribution, ठीक है, then you will convert the frequencies to cumulative frequency and you will find n by 2th observation. ठीक है, you will convert frequency into cumulative frequency, you will find n by 2 and identify the value whose CF just exceeds n by 2. जैसे for example, if I am given x is 1, 2, 3, 4 and इसका frequency given है 2, 4, 5, 2, तो I will find cumulative frequency. ये हो गया 2, this is 2 plus 4, 6, 2 plus 4 plus 5, 11, 2 plus 4 plus 5 plus 2, 13. Now I will do n by 2, 13 divided by 2, 6.5. And find that observation जिसका cumulative frequency exceeds 6.5, माने this, क्योंकि यहाँ पे CF is coming 11. So this becomes my median. ठीक है, the next one that you have is median for continuous frequency. So if you have continuous frequency, then the median becomes lower plus n by 2 minus CF, right, divided by F into H. Where did it go? Into H. Okay. यहाँ पे भी हम लिख लेते हैं. So L is my lower limit of the median class. right? N is my total frequency, CF cumulative frequency hai, but this is of before median class. Okay. F is frequency of the median class. And H is the height. Let's say, for example, if I have to formulate a question, say you're given 0 to 10, 10 to 20, 20 to 30, and 30 to 40. Okay. So you're given some frequency 5, 7, 15, and 13. If I add the frequencies together, 20 plus 20 gives me 40. So n by 2 will be 40 divided by 2, 20. Now I find cumulative frequency. So 5, 12, 12 plus 15, 27 and 40. ठीक है. अब मुझे निकालना है मीडियन क्लास क्या है. So for that it should exceed n by 2. It should exceed 20. So ये रहा 27. So this is my median class. Because its CF is exceeding this 20. ठीक है. Now I will put it in the formula. So L is the lower limit of the median class, माने 20. N by 2 is 20. Cumulative frequency before the median class, माने 12. Frequency of the median class, माने 15. And height of the median class, so this difference, 30 minus 20, 10. This, you solve it and get the answer. Right? So this is how you can find the median. Okay. Now, you can also find median graphically. To find the median graphically, we use something which is known as ogive. Ogive method may we go ahead and we draw the the cumulative frequency curves, the CF curves. So we draw two CF curve. एक को बोल देते हैं हम less than CF curve and एक को हम बोल देते हैं more than CF curve. Right? And wherever these two meet, that is what becomes your median. Okay, so for example, if I have to go ahead and I have to do it for the same one, I'll do it here, huh? So, 1 second, let me do it here itself if possible. Okay, so less than CF. Less than CF means less than 10, less than 20, less than 30, less than 40. So less than 10, less than 20, less than 30, less than 40. Less than 10 में कितना frequency है? How many are less than 10? Only 5? How many are less than 20? These 5 also and these 7 also, so 12. How many are less than 30? So 15 plus 7 plus 5, ये सब less than 30 है. So less than 30 becomes 27. And how many are less than 40? You get 40. Right? Then you make more than CF curve. So you get more than 0, more than 10, more than 20, more than 30. So how many are more than 0? Everything is more than 0, right? So everything is more than 0. How many are more than 10? These are more than 10, right? This is not more than 10. These observations lie between 0 to 10. So how many are more than 10? You get uh 20 and 35. How many are more than 20? These observations lie above 20, right? So how many are more than 20? 28. How many are more than 30? 13. How many are more than 40? 0. Okay. So you have got less than curve and you have got more than curve. Less than curve, if you can see, will be increasing 5, 12, 27, 40. So this is my less than curve 5, 12, 27, and 40. And then there will be a more than curve, which is decreasing 40, 35, 28, 13, and it goes to 0. Wherever these two curves intersect, less than ogive and more than ogive, that value becomes the median, right? That is your median. So median can be found graphically through these ogive curve. Ogive curve क्या करता है? Ogive is nothing but it is telling you the frequencies. There can be a less than ogive curve, which tells you the less than values, and there can be a more than ogive curve. Wherever these two intersect, जहाँ पे भी ये intersect करेंगे, वहीं पे you will go ahead and you will get the equilibrium. Is it clear? वो आपका median हो गया. So these are the different values, formulas for median. Now let's go to mode. Okay, fine. Now mode is what? Mode is the highest value that we go ahead and we have, right? Mode maybe we can go ahead and we can have data which is discrete, or it can be a continuous interval data. So I'll write down all the formulas here. Mode. Mode is something which can be found through the histogram. Okay, so for example, if I make a histogram, and I've taken some observation 10, 20, 30, 40, and यहाँ पे frequency है. So you can see कि this is the highest frequency. So this becomes my mode. Mode के साथ साथ histogram can also represent classes. जैसे for example, this is 10 to 20 का class. ठीक है, this is 20 to 30 का class. This is 30 to 40 का class. Then this will be called as a modal class, क्योंकि इसका highest frequency आ रहा है. So anything with the highest frequency, जिसका भी frequency सबसे highest होगा, that will be your mode. So for example, if I give you the data set 2, 3, 4, 4, 5, 5, 5, 6, 7, 8, 8, 8, 8, 9, 6, 7, 2, 3, something like this. You have to find which is the observation जिसका highest frequency है. Clearly 8 has the highest frequency. So this becomes the mode. When we have a continuous frequency distribution, then the formula of mode becomes L plus F1 minus F0 upon 2F1 minus F0 minus F2 into the height. Okay? Where F1 is your modal class, F0 is your preceding class, and F2 is your succeeding class. ठीक है, तो इसको हम कैसे कर सकते हैं? जैसे फॉर एग्जाम्पल, इफ आई एम गिवन अ डेटा 0 to 10, 10 to 20, 20 to 30, 30 to 40, एंड यहाँ पर आई एम गिवन सम फ्रीक्वेंसीज 40, 30, 50 एंड 40. सो क्लियरली दिस इज द हाइएस्ट फ्रीक्वेंसी, तो ये मेरा मॉडल क्लास हो गया. ठीक है, सो दिस बिकम्स F1. प्रिसीडिंग माने ये हो गया F0, सक्सीडिंग माने ये हो गया F2. क्लास हाइट ये गैप 10 का, एंड लोअर वैल्यू इसका हो गया 20. जस्ट पुट देम इन द फॉर्मूला. सो 20 F1 minus F0 upon 2 times F1, 100 minus 30 minus 40 into height 10. This will be your answer. So this becomes the answer to this question. Okay? Is it clear? This is how you can find the mode. Now last they may ask you question on the relationship between mode, mean and median. So just remember, mode is 3 median minus 2 mean. Okay? If median is equal to mean, अगर हम इसको और इसको equal put कर देते हैं, say some x, then mode will become 3x minus 2x माने x. So mode will also be x. Right? So this is the relationship of this. Now, the last thing that we have is the different types of distribution and the relationship. And इसी से हम types of distribution अब समझने की कोशिश करेंगे. So the distribution can be symmetric. It can be positively skewed, or it can be negatively skewed. अभी के लिए सिर्फ mean, median, mode में I am telling the relation. We'll come to the formulas a bit later. So if I have symmetric data set, it means that mean, median and mode will be equal. If I have positively skewed, to mean is greater than median, will be greater than mode. Mean greater than median greater than mode माने क्या? देखो यहाँ पे ये सारा वैल्यूज है x का वैल्यू 1 है, 2 है, 3 है, 4 है, 5 है. Mean more than median means mean is here, then median is here, then mode is here. And what was mode? Mode was where we had the highest frequency. तो highest frequency यहाँ रही होगी, and then frequencies कम रही होंगी. So this is how the data would look. Similarly, when we say negatively skewed, तो negatively skewed में mean less than median, less than mode. Right? So again, just think about it. Mean is here, then median, then mode. And mode has the highest frequency we know. Mode का frequency means that number which has the highest frequency. तो जो भी यहाँ पे number है, whatever number is here, that number has highest frequency. So it means that the data is looking like this. Right? So this is how you can picturize this data set. And here you have all three equal. This is mean, median, and mode. Okay. Is it clear? Mean, median, mode में सब clear हो गया. So if I come back to the notes, I want you to read this. Read. 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 Okay. Now we'll talk about dispersions. Yes, you can measure, you can tell them like right tail, left tail, वो सब भी you can go ahead and you can say, या skewed data, left skewed, right skewed वैसे भी बोल सकते हो, या negative skewed, positive skewed भी बोल सकते हो. All those are right. Doubt related to quartile, decile, and percentile. Yes, tell me the doubt. Yes, Aditi, tell me what's the doubt.
term value comes, matlab, if if the observations are for like 8 values, and when you are either getting the percentile or the decile in a value that's coming like 8th or 8.9th value, then which value should we be choosing?
Let me see if I've understood your doubt correctly. So you are going ahead and you are saying that you are finding out n plus 1 by 4 and the answer is coming in decimal. Is that what you mean?
Yeah, it's more like if you have a distribution of let's say there are like 5 data sets, and when you are either getting the percentile in a, like, we usually get a 10th value, right, or like some value, and then we choose that value from the data set. If it's the 6th value that's coming, then the 6th value would be the our answer, right? But if we are getting the percentile as a value that's 8.9 term, but we only have 8 terms in the data set, then which value should we be choosing?
Exactly. So basically, you're just asking what happens when you go ahead and you get the question with a decimal. That's it, right? Okay. So, for example, let's take a question in that. Anyone who can answer this? We have done this in class. So let's say you have a data 2, 4, 5, 6, 7, 8, 9, 3, 4, 5, 6, 7. And I ask you to find first quartile. Give it a try, all of you. Give it a try. Yes, good. So whenever you are given a data like this, first of all, you will put them in ascending order. This is in ascending order. Then you will, because I have to find the quartile. Quartile ka formula is n plus 1 by 4 into k, where k means whether it is first, second or third. So if it is first quartile, k takes the value 1. If it is second quartile, k takes the value 2. If it is third quartile, k takes the value 3. So since it is first quartile, k takes the value 1. Number of observation are 1, 2, 3, 4, 5, 6 and 7 plus 1, 8. My bad. This will give. Let me remove 1. यहाँ पे तो you are getting a number directly. So answer will be 4. Let's say the data is this. 2, 4, 5, 6, 7 and 8. And now you have to find the first quartile. So again you will put it in this. So k, n plus 1 by 4. So k will be 1. N will be 6 plus 1 by 4. So this will give you 7 by 4th observation. Can you tell me what is 7 by 4 in decimal quickly? 1.75, right? So now you will go ahead and you will work on this. So 1.75 means that you will take first observation completely, because this is 1, plus 0.75 times second minus first observation. So whatever comes after decimal, usko aap yahan loge. And then you will do second minus first observation. Why second? क्योंकि यहाँ पे हमने first लिया है ना. So second minus first observation. ठीक है. So this will be first observation plus 0.75 times 4 minus This will be your answer. Ab similarly, suppose if I ask you in question, find third quartile. So it will be k into n plus 1 by fourth observation. So k becomes 3, n plus 1 by fourth observation. So 3, n is number of observations are 6 plus 1 by 4. So it will be 3 into 1.75. Okay. Just tell me what number you are getting here. 3.5. So it means it will be third observation because 3 is coming here, plus because 0.5 is coming here, 0.5. ये third है ना, so it will be fourth minus third observation. So third observation 1, 2, 3, which is 5 plus 0.5, fourth minus 6 minus 5. So it will be 5 plus 0.5 into 1, 5.5. Clear? Is it clear now? Oh, okay. So whatever, माने I hope this is clear. Whatever you get here, जो भी यहाँ पे 3 into 1.75 करके आएगा, you just use that to solve. ठीक है? Okay, so I hope now it is clear. So now let's go and talk about the dispersion. When we talk about dispersion, in dispersion, सबसे important, of course, standard deviation ही है, but we must go ahead and know all other dispersions also. It can come as match the following. It can come as just putting them in ascending order. Just they may give you a data. I give you a data 4, 5, 6, 7. And then I tell you, find range, standard deviation, mean deviation, median deviation, and put them in ascending order. ऐसा कुछ भी बोल सकते हैं. Right. So what is dispersion? So dispersion goes ahead and tells me the spread of the data set. How spread is the data set? Right. In which the first thing that we have, that is called as range. So range is lower, range is largest minus smallest, या upper minus lower. ठीक है. रेंज इज वेरी वेरी सिंपल, बट रेंज इज वेरी एक्सट्रीम टू आउटलायर. जैसे जैसे आउटलायर आते रहेंगे तो रेंज को उससे बहुत ज्यादा फर्क पड़ेगा, क्योंकि वो अपर एंड लोअर वैल्यू को ही लेते हुए चल रही है. राइट. सो रेंज इज वन ऑफ द, I can say, one of the tools which should not be used very casually. Unless required, only then you should be going ahead and using range. Okay. Range may, we can also find the coefficient of range, and the coefficient of range is lowest, largest minus smallest upon largest plus smallest. The next one that we have, that is known as quartile deviation. Quartile deviation का formula हो जाता है Q3 minus Q1 by 2. We have just learned कैसे निकालते हैं Q3 and Q1. And the coefficient of quartile deviation is Q3 minus Q1 upon Q3 plus Q1. I wanted to discuss it now, but we have done this discussion, how to find the quartile deviation. Okay. Then you have mean deviation. Mean deviation can be around mean or it can be around median. अगर mean deviation around mean है, then the formula is summation xi minus x bar upon n. And if it is around median, then it is summation xi minus median absolute value divided by n. Okay. Then you have the formulas of standard deviation. Standard deviation का most easiest formula is summation xi minus x bar whole square by n. This is called as variance. And when we find its under root, then we go ahead and get standard deviation. Right? Standard deviation is the most often and commonly used tool. अब एक चीज स्टैंडर्ड डिविएशन में याद रखना है, which we usually do in hypothesis testing, that the formula differs for population and sample. अगर population है, if it is population, then it will be summation xi minus x bar whole square divided by n. This will be variance and its under root will be standard deviation. But if it is sample, so then it will become summation xi minus x bar whole square divided by n minus 1 and its under root will become the standard deviation. Okay. Whenever you have to find coefficient of anything, okay. So coefficient किस किस का बोल सकते हैं? They can ask you to find coefficient of range. वो हो जाएगा largest minus smallest upon largest plus smallest. Coefficient of quartile deviation, Q3 minus Q1 upon Q3 plus Q1. Coefficient of mean deviation, it will be mean deviation upon mean if it is around mean, and if it is around median, so it will be mean deviation upon median, right? And at last, coefficient of variation. Agar coefficient of variation hai, it will be sigma by x bar into 100, where sigma is standard deviation, right? So these are some of the coefficients which can be asked in exam. Is it clear? Please make a note of all these formulas, put them in one formula sheet for your exam perspective. Okay, so let's do some true false. First, mean deviation is minimum when taken from median. Hanji, is it true or false? अच्छा ठीक है. Question. Data I'm giving you. 2, 4, 6, 8, 100. ठीक है. Find mean deviation around mean. Find mean deviation around median. Give me the values. Hanji, what answer are we getting? Mean deviation around mean nikalo. Find the mean. 2 plus 4 plus 6 plus 8 plus 100 divided by 5. So 8, 9, 10, 20, 120 by 5, 24. Mean deviation around mean means summation xi minus x bar absolute value divided by n. This is the formula we have studied, right? So what will happen? 2 minus 24, 4 minus 24, 6 minus 24, take them in absolute values. 8 minus 24, 100 minus 24 divided by 5. Tell me the answer. फिर around median तो third value हो जाएगा in this case. So 2 minus 6, 4 minus 6, 6 minus 6, 8 minus 6, 100 minus 6 divided by 5. Tell me the answer for both. Okay, for the first one, it is 30.4. What about the second one? 20.4. Is it less with mean or median? Median. So ये एक property हो गया that summation xi minus a in absolute value is least when a is median. When you find deviation around median and absolute value, it is the minimum. ठीक है? Okay, tell me if this is true or false. Summation xi minus a whole square is minimum when a is mean. Good. True. Sum of squared is minimum when taken around mean. Very good. ठीक है, अच्छा ये बताओ. Summation xi minus a is 0 when a is mean. Correct. True. So if I don't take absolute value, अगर मैं directly add करूं without taking absolute value, then the sum of deviation from mean is always 0. So sum of deviation from mean is 0. When there is no absolute value. Okay? But if someone gives the question about mean deviation from mean and mean deviation around median, then mean deviation around median is the least. Okay? Okay. So we'll take a break and we'll come back at 3:30. And then we'll start with skewness and kurtosis. Hi, please ask everyone to join in. And just post it in the group once and starting the session. Ask everyone to join in. Okay, so before we do skewness and kurtosis, we'll begin talking about movements. Now, when we talk about movements, सबसे पहले we want to understand what are raw movements. Raw movement is any movement when we go ahead and when we find the direct movement. Direct movement mane when we just find the expected value. Expected value mane we just find the mean in a way. So the raw movement can simply be written as the expected value. Like for example, the first movement, first raw movement, that can be written as summation x by n, right? The second raw movement will be summation x square by n. The third raw movement will be summation x cube by n. Fourth raw movement will be summation x to the power 4 by n. These are the first four raw movements. You can see clearly that this is called as mean, summation x by n, right? And the second raw movement is used in variance. Third raw movement skewness and fourth raw movement in kurtosis. We'll talk about that. So ये हो गई raw movement when we directly find raw values. Then we have movements around the mean or movement about the mean. So if they ask you find the first movement around mean, mane it is summation xi minus x bar to the power 1 by n. And we know कि sum of deviation from mean is 0. ये information तो हमें पहले ही पता है. So we can go ahead and we can say कि this will directly be 0. If in exam they ask you to find the second movement around mean, so it will be summation xi minus x bar whole square by n. And this we know is called as variance. If they ask you find the third movement around mean, right, then we can go ahead and we can say that it will be your summation xi minus x bar to the power 3 by n. Fourth to the power 4. That is how we go ahead and we do. Okay. Sometimes they may ask you find raw movement around some random number, around some assumed number. तो वो भी कर सकते हैं. अगर mean की जगह around some number निकालना है, then I will just use that number. Okay. So movements can be raw. Movement can be around mean. Movement can be around median. Movement can be around any number also. जिस भी number के around होगा, you will find deviation through that number. ठीक है. There is a relationship that we have between the raw movement and central movement, and वो relationships बहुत important है, most of the competitive exam ask you that relationship, ठीक है? So I have already noted those relationships here in your notes. Those relationships I have written here, I want all of you to remember them. How to convert raw movement and central movement, कैसे वो कर सकते हैं? Those relationships are mentioned here. I'll give you one example. So I know, like, let's say that the raw movement is represented like this. So what is the first raw movement? Suppose dash represents raw movement. The first raw movement will be summation x by n. And I know second raw movement will be summation x square by n. Right? Now, when we have to go ahead and when we have to find the movement around mean, okay, that means suppose let this represent mu2 represent second movement around mean. That means I am doing summation xi minus x bar whole square by n. So summation x minus x bar whole square by n. Now you know that if I open this up, I can write this as summation x square plus x bar square minus 2x x bar upon n. So I can write this as summation x square by n plus summation x bar square by n minus 2x bar summation x by n. That means I can write it as summation x square by n. Since x bar is getting summed up, matlab it is getting added up n times, so it will be n x bar square by n minus 2x bar, and this is nothing but x bar. So ये हो जाएगा summation x square by n plus x bar square minus 2x bar square माने summation x square by n minus x bar whole square. Now I know कि this is the so summation x by n माने x bar, this is the first raw movement. तो इसकी जगह पे I can plug first raw movement. X bar is nothing but first raw movement, and summation x square by n माने this is nothing but the second raw movement. So we have found out the relationship between movement around mean with raw movements. ये एक derivation है, एक का derivation I have shown you. Similarly, others can be derived. So those you don't have to understand derivations, but you just have to remember these formulas. ये formulas important है, ठीक है? Is it clear? So you have to remember the movement ka formulas. Now, once you have understood this, let's move on to skewness. So let me explain you something today. So देखो, when we talk about mean, median, mode, this is one data point. माने mean, median, mode in a way मुझे बता रहा है कि what is that central value. So suppose it tells me the central value. Where my data center values line, that is the aim of mean, median, and mode. When we talk about deviation, like standard deviation, mean deviation, it tells us how much data is spread around that central value. उस सेंटर का वैल्यू से डेटा राइट साइड पे कितना है और लेफ्ट साइड पे कितना है. सो द डिविएशन टेल्स मी द स्प्रेड, हाउ माई डेटा इज स्प्रेड, मेरा डेटा कैसे स्प्रेड है. When we talk about skewness, skewness tells me how the data is symmetry. So is the data symmetric like this, or like this? माने वो जो frequency distribution है, where it is the highest. Is it highest first and then low, 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 low? Is it highest in the center or is it highest towards the end? So skewness tells us the symmetry of the data set. And when we talk about kurtosis tells the peakness of the data. Mane, is my data like this? Is my data like this? Is it very peaked, less peaked? The peakness of the data set, that is by kurtosis. So these four things together can help me understand the exact shape of the data. Center value, center ke around how much spread is there? Is it spread towards the left or right? Symmetry kya hai? And is it peaked or flat? Wo kya hai? So these four things are important. Now, when we talk about skewness, I have already told you that skewness can be either it can be symmetric, yeah, it can be positively skewed, or it can be negatively skewed. Okay, positively skewed means right tail is longer, negatively skewed माने left tail is longer. ठीक है, अब skewness का भी there are various formulas. तो जो सबसे पहला formula है, that's a Karl-Pearson formula, which says mean minus mode upon standard deviation. But if mode is ill-defined माने कभी कभी your data can look like this, जिसमें दो values have highest frequency, right? I may not be able to tell mode in that case. So when it happens that mode cannot be defined for a data set, then we can use the formula. We know mode, median and mean के बीच का relationship. I know how mode can be converted in terms of median. 3, right? So we can go ahead and we can convert this and we can say 3 mean minus median. I can replace mode by that formula by standard deviation. This is skewness. This is the formula of skewness by Karl-Pearson. उसके बाद Boley also gave the coefficient of skewness and he gave it based on the quartiles, right? So according to him, skewness is Q3 minus Q1, right? Sorry, Q3 plus Q1 minus 2Q2. ठीक है, इसको actually I have summarized it. Books कैसे लिखेंगी इसे? Books will write it like this: Q3 minus Q2 plus Q1 minus Q2. माने difference between third and second and first and second. ठीक है, divided by Q3 minus Q1, the bigger gap. Right? So this is basically your Boley's coefficient of skewness, and we know that Q2 is nothing but also called as median. Right? So you can remember it like this, that if I have Q1 here and Q3 here and Q2 here, so numerator is this difference and this difference, and denominator is this, right? So this is what the formula of skewness is, coefficient of skewness is. Now, the next one is called as Cayley's coefficient of skewness, which is based on deciles and percentiles. So we can go ahead and say that this will be D9 plus D1 minus 2D5 upon D9 minus D1 and P90 plus P10 minus 2P50 upon P90 minus P10. ठीक है, then we also can define skewness based on the moments, right? Moments अभी हमने बताया ना, so then that can be defined as mu3 upon mu2 to the power 3 by 2, right? If this value is 0, it means it is symmetric. If it is greater than 0, it is positively skewed. Less than 0, it is negatively skewed. ठीक है, where mu3 and mu2, you know, these are the central movement around mean. सेंट्रल मूवमेंट अराउंड मीन, माने म्यू2 को कैसे लिख सकते हैं हम? इट विल बी समेशन x माइनस एक्स बार टू द पावर 2/n, और म्यू3 को कैसे लिख सकते हैं? समेशन x माइनस x3 टू द पावर 3/n। ठीक है। फॉर अ नॉर्मल डिस्ट्रीब्यूशन, जब हम नॉर्मल डिस्ट्रीब्यूशन की बात करते हैं, दिस वैल्यू इज 0, न्यूमरेटर जो है वो 0 होता है। That is why you will get this as 0. So it will be a skewed, it will be a symmetric data set. The skewness will be 0. Okay. So this is some of the formulas that you have to remember from the point of view of exam. Any doubt in this? Okay. DNP. Yes, so D is just the decile. So जैसे when we find the decile, the formula is K n plus 1 by 10. Decile means 10 parts, right? So if I have to find the ninth decile, it will be 9 n plus 1 by 10, where n is number of observation, right? If I have to find first decile, it will be 1 into n plus 1 by 10. Fifth decile, 5 into n plus 1 by 10. Similarly, for percentile, it is k into n plus 1 by 9 by 100. So if I have to find 90th percentile, 90 into n plus 1 by 100. If I have to find 10th percentile, 10 into n plus 1 by 100, where n is number of observation. Yes, that's right. 3 by 2 is in power. तो माने एक तरीके से if you see, when I put the power as 3 by 2, I am finding the variance and then its power is 3 by 2. Correct. ठीक है? Hopefully by tomorrow, you should get a complete MCQ practice on all of this and just do them. So stats ka full revision will be done by all of you. Okay. So do this. So mean is 50. Median is 45. Standard deviation is 10. Find coefficient of skewness. No, only to that one. ठीक है. Good. All of you are right. Answer will be 3 mean minus median upon standard deviation. So it will be 350 minus 45 divided by 10, 1.5. ठीक है, good. So try another one. So for example, you have Q1 as 20, Q2 as 30, Q3 as 50. Find Bowley's coefficient of skewness. Bowley's coefficient of skewness. Hanji, what's the answer? Okay, why are you taking so much time? 50 plus 20 minus 60 upon 50 minus 20. 10 by 30. 1 by 3. 0.33. What's taking so much time here? Okay. So I hope that this is absolutely clear to you. Manesh, there is not a lot of things which is to be told, right? You can always go ahead and remember the different formulas. Now let me go ahead and talk about Kurtosis. So as I said, Kurtosis talks about the peak of the data set, whether it is peaked, whether it is flat, whether it is too flat. वो Kurtosis है. So in a way, it is telling you about the concentration of data set around its central value. कि क्या, if most of the data is around the central value, then it will be concentrated. If the data is not concentrated, it may look like this, right? So in a way, it is telling me the peak. Now, Kurtosis में we use the parameter जो हम use करते हैं, that is basically beta 2. So if beta 2 is 3, right, then it's called as mesokurtic. Mesokurtic means it looks like a normal data set, normal peak. When beta 2 is greater than 3, then we say it is leptokurtic. Leptokurtic means high and sharp peak, right? This is a normal data. And when we have platykurtic, that means beta 2 is less than 3. That means it is flat and spread out data set. ठीक है, तो normal distribution is mesokurtic. अब हम कैसे कैसे इस चीज को निकालते हैं? So beta 2 is mu4 fourth central movement. mu4 क्या होगा? Summation xi minus x bar to the power 4 by n. ठीक है, divided by mu2 to the power 2, where mu2 will be what? xi minus x bar to the power 2 by n. Okay. And we can also find something called as gamma 2. ज्यादातर हम प्रैक्टिस में gamma 2 यूज करते हैं. Gamma 2 is nothing but whatever beta 2 you get minus 3. है ना? तो अगर beta 2 3 है, so what will be gamma 2? 3 minus 3 0. If beta 2 is more than 3, what will be gamma 2? More than 0. If beta 2 is less than 3, what will be gamma 2? Less than 0. So sometimes books also represent the question in terms of gamma 2. Is it clear? So this is all about Kurtosis. Okay. They can go ahead and ask you directly beta 2. Yeah, they can go ahead and ask you gamma 2 in this case. Okay. So let me give you one question based on it. So let's say that you are given that the gamma 4 is 30 and you're given that variance is 10. You have to find Kurtosis and tell type of data, whether it is meso or whether it is plateau or whether it is lepto. You have to tell what kind of data it is and you have to find the value of Kurtosis. How about others? Use the right formula. So you have to basically type find Kurtosis means you have to find beta 2. They haven't asked you to find excess Kurtosis. इसको बोलते हैं excess Kurtosis because you subtract 3 from it. यहाँ पे you just have to find beta 2. So what's the formula of beta 2? Mu 4 upon mu 2 whole square. and mu2 is nothing but it is the variance. And here variance is given to me as 10, right? So this is 30, mu2 is variance is 10 whole square. So 30 divided by 100, so 0.3, which is less than 3. Yes. So don't say answer is 3. You have to divide it by mu2 square, where mu2 itself is sigma square. mu2 ही sigma square है. That is why I gave this for confusion. mu2 itself is the variance, but denominator is the square of the variance. Okay? Okay, we'll do just one more question on this. So assertion. A leptokurtic distribution has more extreme values. Reasoning. Leptokurtic distribution has heavier tail. Both assertion reasoning true, but reasoning doesn't explain assertion. Here reasoning explain assertion. Assertion true, reasoning false. Both assertion reasoning false. What was first Kurtic? There is nothing called first Kurtic. Just it's Kurtosis. I didn't understand. First Kurtic माने? There is just formula of peakness. Peakness का formula ये है. Beta 2. That's it. There is nothing called beta 1. ऐसा नहीं है. Beta 2 represents Kurtosis. अच्छा, sorry. This is meso, MESO. This is lepto. This is platy. Platy means like a plateau. Plateau flat होता है, right? It's like a plateau. A leptokurtic distribution has more extreme values. More extreme values माने the frequency of these distributions is high. इनका frequency high है, right? The frequency of these distributions of extreme values is high. So it has heavy tails. Agar tail will be heavier, more observation will be on tail, so less will be there in the center. So what about the statements? Is it true or both are false, or what should happen? Think. What about others? Good. This is clearly plateaukurtic, right? It has flat curve. Data is more spread out. Extremes में ज़्यादा frequency है, right? So you're right, all of you, that this is a false statement. It doesn't have more, because it has more extreme values, it should be plateaukurtic, right? and heavier tails should also be platykurtic. So lepto would be the wrong answer in that case, right? So which distribution has more extreme values? माने ज़्यादा frequency वहाँ पे दिखती है. It is platykurtic. अच्छा, एक चीज है which I think most of you can get confused. Here, extreme value does not mean outlier. There is a difference between two. Extreme value में I am just saying कि if my data is suppose 0, 1, 2, 3, 4, suppose ये x है, it means that extreme ones have more frequency. माने suppose 0 का frequency 10 है, 4 का frequency 10 है, and 1 का frequency 5, 2 and 5 है. So the extremes have more frequency. This is what I am saying. This is what Kurtosis tells. Whereas outlier का मतलब होता that I would have had data 1, 2, 3, 4, 5 and one would have been very different from others. So extreme value does not mean outlier. Extreme value का high frequency just means that whatever values are coming towards the end of the data set may not be outlier. माने वो data set से match हो रहा है, they are matching with the data set, just that they have higher frequency. उनका frequency high. This is what we go ahead and we mean here. Is it making sense? So extreme does not mean outlier. Please clearly understand this thing. Okay, good. So we are done with Kurtosis. So if I just come back to the notes then, you read all of this. This is the most important analysis. You read this and you read everything related to Kurtosis and everything related to skewness with all formulas. Okay. And with this, we have come to the end of the first important analysis. जो हमें पहला करना था, we have done everything in it. We have done mean, median, mode, skewness, kurtosis and movements and standard deviation.